In this video, we'll take a quick look at some software that can help you to generate Halton points for any survey area, and so it can help you with macro-level survey design. The software is a web-based application written in Shiny. The material that I'll present closely follows the material in this cheat sheet, so if you're in any doubt, consult the cheat sheet. There are three different ways of running the app. The easiest is to take this link and paste it into a web browser. You won't need any other software installed to do this. For the other two methods, you need to have R installed as well as some other packages, and these are listed in the cheat sheet. The second way just requires you to enter in these two lines of code into the R console. The third way, you need to download the code to run the app from this GitHub repository and save it locally on your machine, and then open it up in R and run the app. So let's have a look at the app and see how we can use it to generate Halton points. Once you've loaded the app, you should see a map that looks something like this. The map is interactive, so you can zoom in or zoom out and drag the map around. There's also different base maps, so you can switch between this view and one that gives you some topographical information. To generate Halton points, all you need to do is to load in a shapefile that contains your survey region. So you click on the Browse button and then browse to where you have your survey region stored. You need to select these four files, DBF, PRJ, SHP, and SHX files, and then click Open. This will load the survey region and zoom into it. To generate some Halton points, we just need to decide how many we want to generate. Remember that we can always generate more Halton points later on. So let's start with 20. To generate 20 Halton points, all we have to do is click Add Surveys. But before we do that, we need to make a note of the random seed that we're using to generate these Halton points. Remember, the random seed tells us where in the Halton sequence we start, and it's a way of getting some randomization into the survey design. There's a default value in the box, but you can change this to whatever you want. But it's really important to make a note of the random seed, because that's the only way that you'll be able to reproduce your results later on. So once we've decided that we want 20 points, we click Add Surveys, and that will generate 20 Halton points that are spatially well balanced. If we want to generate another 10 points, we just enter 10 to the box and add those surveys. The old Halton points, the first 20, will turn blue and the next 10 will be indicated in red. We can always hover the mouse over a survey point to get its ID and a lat-long coordinate. Once we've decided that we've generated as many Halton points as we need, we can download those survey points using this button. So that's the basic usage of loading a survey region and generating Halton points in that region. Now let's look at two slightly more advanced features. One thing that we might want to do is exclude some parts of the survey region that have already been sampled. So to do that, let's first clear the surveys that we've generated and load the locations of places that we've already been to. Now, this takes the form of another shapefile which contains the regions that have already been sampled. Again, we need to specify these four components of the shapefile and click Open. You'll see that on top of this survey region, we've got a few grey areas here, here, and here that indicate parts of the survey region that have already been sampled. So now, if we generate, say, 50 Halton points, none of the survey regions that have already been sampled will contain any Halton points. Those will be avoided. So this gives us a way of avoiding areas that have already been sampled while maintaining spatial balance. Another thing that we might want to do is to stratify the survey region. In order to do this, we need to have a shapefile for the survey region that has an extra variable called stratum ID, and this will contain information that allows us to create the strata. So in this example, what we're going to do is to stratify by a predicted occupancy probability. So I'll load a shapefile in the usual way, but you'll see that there are three strata here. The green cells have low predicted occupancy probabilities between 0 and 0.33. The red cells have medium predicted occupancy probabilities between 0.33 and 0.66. And the blue cells have high predicted occupancy probabilities between 0.66 and effectively 1. 38% of the survey region is green cells, 39% of the survey region is red cells, and 23% of the survey region is blue cells. Now here, just to emphasize, we've used predicted occupancy probabilities to stratify the survey region, but that's not a requirement. You can stratify by any categorical variable. So now we can generate halting points in the usual way. Say we generate 100 points and click Add Surveys. This looks pretty similar to what we had before. Points are pretty evenly distributed throughout the survey region. And the reason for that is, by default, the number of points in each stratum is proportional to the area occupied by that stratum. So because the green cells occupy 38% of the survey region, 38% of the halting points are generated in green cells. So there'll be 38 halting points in green cells. There'll be 39 out of 100 halting points in red cells and 23 out of 100 halting points in blue cells. So this is just because by default we generate halting points proportional to the area occupied by each stratum. But this box over here allows you to override that and to preferentially sample some strata. So let's clear the surveys and say, or maybe we want to preferentially sample high density areas. So let's take an extreme example where we want to generate 10% of our survey points in low density areas, 10% of our points in high density areas, and 80% of our halting points in high density areas. And this is just a vector of length 3 in R syntax, with 10% in the first position, 10% in the second position, and 80% in the third position. I click Update to load that information, and then Add Surveys. And you'll see here that halting points are overwhelmingly in the blue cells. So what's important here is that there are only 10 halting points in the low density areas, but these will be evenly distributed spatially throughout the low density areas. Similarly, for the medium density areas, there'll only be 10 halting points in the red cells, but these will be evenly distributed spatially across the red cells. And there'll be 80 halting points in the blue cells, again, evenly spatially distributed within that stratum. So we can generate however many points we want in each of the strata, and we can be guaranteed that within each stratum those points will be spatially well balanced. And that happens even though we've got very discontinuous survey strata.